Hello, welcome to my YouTube channel. My name is Nenye Abraham. I will be your mathematics teacher for today. Today we are doing a new topic, a matrices called variance covariance matrix. Variance covariance matrix. Variance covariance matrix. Please, I would love that you follow me very carefully as I go through this lesson. Please subscribe to my YouTube channel if you haven't, and turn on the notification bell to be notified whenever I release a new video. Now, what is a variance covariance matrix? Now, I will state the variance covariance matrix. And the variance covariance matrix is in this form: X, Y, Z. X, Y, Z. Here you have X, 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 Y, X, Z. You have YX, YY, YZ. Have ZX, ZY, ZZ. So looking at it, you realize that the leading diagonal are variances. They are covariances of themselves. So we call them what? Variances. So the leading diagonals are what? Variances. All the leading diagonals of a variance covariance matrix are variances. And then the other entries are all covariances. Now we want to look at some of the properties of variance covariance matrix. Properties of variance covariance matrix. Now, the first property is they are always square matrices. They are always square matrices. Now, there is nowhere you will see a variance covariance matrix is not being a square matrix. Being a square matrix means that it has the same number of rows as the same number of columns. So the number of rows and the number of columns of that matrix is or are equal. Then we say it's what? It's a square matrix. And then variance covariance matrix has the same number of what? Rows and columns. So we say they are what? They are always what? Square matrix. So if you solve something for if you have been given a data set to solve for variance covariance matrix and you solve and the answer is not a square matrix, then you should know that you are wrong. The matrix is symmetric. The matrix is symmetric. I hope that I did symmetric matrices in one of my videos. You can go and check and you understand what symmetric matrix is. It is positive semi-definite. It means that I've not done this and I wouldn't explain it to details, or you can also possibly go and look on it. But it has, when they say something is positive definite, one way to check is using the eigenvalues. The eigenvalues, when you use the eigenvalues, you realize that one of the eigenvalues is positive and one of them is negative. So it's semi-positive. So in that way, we say it is semi-positive. All eigenvalues of the variance covariance matrix are real and non-negative. They are real and non-negative. Like I said, when you check the variances of the matrix, you will see that they are real numbers. They are not, they are real numbers. They should be from negative 1 and they are non-negative, so there is no negative inside calculating. So we'll come to eigenvalues, but for now the most important thing you should know is they are what, always square matrix, and they are what, they are symmetric what, matrices for now. And how do we represent the this thing, the variance covariance matrix? That was what I did in the first thing I did. This will be variance of x. This will be variance, the diagonals are always variances, variance of y, and then variance of z. Here will be covariances of x, y. So the rest are covariances. The rest are covariances. And this is a symmetric. So if you know the value here, you should know the value here. It is only these values that are different. If you know the value here, you should know the value here. I hope you understand. So these are what, this is how to represent the variance covariance matrix. Now you can be given a data set. And then you will be asked to find the variance covariance matrix from that data set. Now let me use this example. The table below displays scores on math, English, and arts test for 5 students. The number of students are what, 1 to what, 5. Then these are the marks when it comes to mathematics. These are the marks when it comes to what, English, and these are the marks when it comes to arts. There are a lot of softwares that can be used to find the variance covariance matrices, especially Excel, Microsoft Excel. And then, but for now, you can be asked in the exams to find this. That is why we are doing this. So this is a data set. How do you convert the data set into what? Variance covariance matrix. What you need to do is, I first find the total. Let me not go this way. Now there is a matrix called a deviation matrix, and let me represent it by A. Now to find a deviation matrix, it is equal to A, the matrix from the data set, minus unitary matrix. This matrix is called unitary matrix, multiplied by A, multiplied by 1 over the number of population, the sample population, or the population given. So that is the deviation matrix. So that is how to find the deviation matrix. Now, so this in general can be written as A. Now you realize that from the data set given here, it can be converted into matrix by just bringing the same thing this way. So this is just from writing the same thing here as a matrix, and that is, I've represented that as what, my A, matrix A. And in the equation, or in the formula, you see that this is A minus unitary what, matrix. The unitary matrix is a matrix of what, 1 1 1 1 1 1. All the entries of that matrix is 1, minus the unitary matrix multiplied by the same matrix A, and then everything multiplied by what, 1 over the number of what, sample, 1 over the number of sample. So I've written down the matrix here, and then we have what? We have the deviation matrix here. Deviation matrix here. Deviation matrix here. Now after the deviation matrix, how do I find the deviation matrix? So I brought my this thing minus the unitary matrix. Why do you bring the unitary matrix? The unitary matrix, we brought it because we had wanted to what? Find the transpose of this what? The same matrix, matrix A, to find the transpose and sum every item in the transpose, divide it by the what? The number of what? Samples, or divide it by 5. So here the students are 5. 1, 2, 3, 4, 5. So that is why we used 5 here. Now if the students were to be 6, here would have been what? 6. So if you multiply this, so look at this, look at this. So from the question, I have total marks. This was the total marks of each student. This was the total marks of each student. Now average marks, that is the mean of every what? Subject, is this what we have here. The mean of what? Every subject is what we have here. Now you realize that if you find the transpose, or if you multiply this unitary matrix by this and divide it, you multiply sum, divide it by the what? The 5. You realize that you still get the same thing here. So for example, the first one, if you pick the first what? Row, matrix multiplication. If you pick this one and multiplied it by this, so it will be 1 by this plus this plus this plus 60 plus 30. We are going to get what? 330. We'll get 330. Now 330 divided by 5, you are going to get what? 66. 330 divided by 5 will give you what? 66. Now the same thing, use the same thing to multiply this column. You still get 60. If you use the, you get 60. If you use it to multiply this column and divide it by 5, you get what? 60. What I'm saying is that matrix multiplication, if you pick this row, you multiply it by the column here, all the columns here, and divide it by 5. So for example, if I pick what? The first row, it will be what? 1 times what? 90 plus 1 times 90 plus 1 times 60 plus 1 times 60 plus 1 times 30, and that will give us 360. All what we are seeing here will give us what? 330, rather 330. Now divide it by the what? The 5 here, or multiply it by the 1 over 5. It will be what? 66. It will be 66, and that is for the first row. You are taking this same thing, multiply it by this and add, and you are going to get 60. If you do the same to this row, you get what? 60. You now come and pick this row to do the same thing. So you realize that this thing will be repeating. The mean or the average marks will be repeating. So the whole of these two matrices, and with the constant here, will be repeating as this: 66, 60, 60, 66, 60, 60. The number of times of the number of rows. So we have 1, 2, 3, 4, 5. We have 5 rows, so it will repeat like 5 rows. So the whole of this thing will give us this matrix. In all of our solutions, in any of the questions, the same things happen. The same thing happens. So what you need to do is that this thing, you don't need to do it. You just need to know the mean from what? The question. And then when you get to this place, just substitute this thing, the number of times of the number of rows we have in the what? In the matrix. And then you are good to go. Now, if you substitute that here, you will now have this. Now, subtract this from this. When you subtract 90 minus 66, you get 24. 60 minus 60, you get 0. So if you do all the subtraction, this is the matrix you get. You're going to get this matrix. Now let's continue. Now, after the subtraction, we had this matrix here. Now, then to find the deviation score, sums of squares matrix, we call this matrix deviation score sums of squares. The sum of square matrix, let's call it that way. To find the sum of square matrix, so the reason why we are finding this matrix is that before we can find the variance covariance matrix, variance covariance matrix is multiplying the number of what? Sample we have by the what? The sum of squares matrix, which is A transpose A, the deviation matrix we had. So from the deviation matrix we had, you would transpose the deviation matrix and then multiply it by the deviation matrix. And this matrix is what we call sums of squares, sums of square matrix. And then multiply it by the fraction, or 1 over the number of sample we have. So this is variance covariance matrix. I will name it V or VC. Let me name it VC. This is the formula for variance covariance matrix. This is why we are solving all these things. So the variance covariance matrix is this. So when you transpose this matrix, when you transpose the matrix we had here, let's transpose it somewhere here. This is the matrix we have here. When you transpose it, it will be 24 minus 6 minus 36. Then we have 0 0 0 minus 30. Then we have 30 minus 30, 0 0 0 30 minus 30. So this is it. When you transpose it, this is what you get, and you see that this is the same matrix we did here. We transpose it, and this is what we have. After our transposition, this is what we have. Multiply it by the same matrix. If you multiply it by the same matrix, I don't need to do matrix multiplication here. If you multiply it by the same matrix, this is the matrix we're going to have. This is the matrix we're going to have. We have 2,520, 1,800, 900, 1,800, 1,800, 0. This is the 3 by 3 matrix we have. Now, this tells us that we are going closer to the what? The variance covariance matrices. So, I stated here, And finally, to create the variance covariance matrix, we divide each element in the deviation sum of squares matrix. So the sums of square matrix we had here, which is what? The deviation sum of square matrix we had here, which is A transpose A, this matrix. We divide it by n. That is the number of what? The number of what? Samples we have. So n is what? 5. So I divided it by n. And dividing it by n, each entry in the what? In the matrix will be divided by what? N. Each entry in the matrix will be divided by n, which is what? 5. So I divided each entry by n, and this is what I had. Now, using calculator to find your what? Your division, this will be the matrix. And this is the matrix we call what? Variance covariance matrix. Variance covariance matrix. Now, this is one example. Let's go to another example. So this is another example. Given data set of 3 measurements, scores on math, English, and physics. These are the scores: math, English, and physics. We have what? 5 students. We want to get the variance covariance matrices, or construct variance covariance matrices from this. There is something I will explain to you at the ending part of this lesson, this question. So please do follow. The reason why we, in the first place, we are even supposed to find variance covariance matrix. This is just a few number of data sets. You could be given like 1,000 data sets to do the same thing on, and that is where we use softwares. We'll come to the software, but for now, let's concentrate here. Please, I hope you understand me so far. So the reason why we are even looking for variance covariance matrix, I will explain that at the end of this lesson. So please, we have variance covariance matrix, and we said to get the variance covariance matrix, this is what we are looking for. Variance covariance matrix, I've named it as what? VC, is equal to the deviation sum of square matrix. Deviation sum of square matrix divided by n. This is it. And so the first thing we want to look at is how to get the deviation matrix. How to get the deviation matrix. And we said that the deviation matrix is equal to 1, the matrix given, which is A, the matrix gotten from the data set, minus the unitary matrix, times the matrix gotten from the data set, the mean matrix, multiplied by n. So this is the matrix we had from the data set. That is 90, 90, 60. Formulate the matrix from the data set. 90, 90, 60, the column. 3 columns, and then about 5 rows. To calculate the deviation matrix, this is what we do. This is the formula for deviation matrix I've stated here. Now, you just substitute the formula inside. So I told you that this matrix here, this whole thing here, all they are just doing is finding the what? The mean of every what? Every data set, every subject here in a matrix form. So I've found the total of every subject, which is 300, 250, and then 350. That is the total of finding the mean, we have to divide it by the number of what? Subjects. And so I was telling you that even if you take this thing and multiply it by this and divide it by 5, this is what you still get. You still get what? 60, 50, and then what? 70. So it is just the same thing by taking the what? The unitary matrix, multiplying it by the main matrix, and then dividing it by the number of what? Samples we have. So to find the unitary matrix, this is what I've just done. We have, I said to find the unitary matrix. To find the deviation matrix, I told you the whole of this is now this. Just repeat the same thing: 60, 50, 70, 60, 50, 70, 60, 50, 70, up to the number of rows we have. Then after this, when you subtract, this is what we will get as the matrix. Now find the transpose of this matrix and multiply it by the same matrix. You find the transpose of the matrix gotten and multiply it by the same matrix. Now if you find the transpose of the matrix and you then multiply it by the matrix, this is what you will get. This is the matrix you get by finding the transpose and multiplying it by the same matrix. This is the matrix you get. So you realize that the diagonals are all variances. The diagonal are all what? Variances. Now, the other entries are the what? The covariance. So, the first entry in the leading diagonal is 720. We say covariance of mat. So because it is the same, covariance is just a type of variance which is multiplied by another what? Variance. So having a covariance of two things, multiplying it itself is a variance. It's a variance. So these are variances. The diagonals are variances. The diagonals are variances. Now this is a the 480 here is a covariant of what? Mathematics and physics. Mathematics and physics. And then this is the covariance of what? Mathematics and English. This is a covariance of mathematics and physics. So what they are trying to say here by saying that the matrix is a symmetric matrix is that it means that the covariance of English and mathematics is the same as the covariance of mathematics and English. So it's just a commutative property. This is the same as this. The covariance of physics and mathematics is just the same as the covariance of mathematics and physics. Just like here, this one. These are equal. This and this are also equal. Then this and this are also what? Equal. So we say that covariances, the matrix is what? A symmetric matrix. So that is what the diagonals is equals to variances. Of diagonals, covariances. Positive covariance means they tend to vary in the same direction. So what does it mean by positive? So the reason why we even calculate or we find the variance covariance matrix is that we want to know the variances in between the what? The subject or the scores of the student. So let's say the score of the student between the covariance 480, which is a positive covariance, means that whenever a student gets, because it's positive, it means that whenever a student gets mathematics high mark, the student will get physics also high mark. But here it means that if the student gets mathematics high marks, it's possible the student will get English a very low mark. So they are what? They are what? They are different. Their covariance are of different what? Direction. They are moving in different what? Direction. So positive covariance means they tend to vary in the same direction. Otherwise, it is negative covariance. Then they don't vary. When they don't vary in the same direction, then it is what? Negative covariance. So let's look at it. We are saying that any time a student gets physics high mark or mathematics high mark, we'll get physics 2 high mark. Let's look at the marks we have. Now, this student had mathematics 90. The student had physics to be 80. He had this 90, here 60. You understand? So if he get low mark, he will get here low mark. If you get here high mark, you get here high mark. So that is what we are just saying by saying covariances. But for, let's see, the covariance between what? English and mathematics. They vary in different directions. So you see that he had here 90 and had here 40. They are in different directions. It's a negative what? Covariance. It's a negative covariance. So that is why we are what? We are doing variance covariance matrix. Please leave a notification in the comment section if you don't understand anything. Notify me in the comment section and I'll reply you as soon as possible. The name again is Nenye Abraham, and I'm very glad you are following me. Thank you very much, and please subscribe to my YouTube channel if you haven't. Kindly subscribe, and also please kindly turn on your notification bell. Whenever I release a new video, you'll be able to go through. Thank you.